Okay, this section is on adding and subtracting polynomial expressions. It's 6.3 of your workbook, page 79. So here are some notes. Here, a monomial in one variable is the product of a coefficient and a variable raised to a positive integer exponent. A monomial is of the form ax to the k, where a is the coefficient, x is the variable, or we call it the base a lot of times right there, and k is the degree of the monomial. Recall k is a positive integer. A binomial in one variable is the sum of two monomials. A polynomial is the sum or difference of monomials. The degree of a polynomial is the highest degree of all the terms in the polynomial. Determine whether the following expressions are polynomials. Now, one thing I want to clarify here is that we're actually looking at they could be monomials or polynomials is what we're looking at. We're looking for things that are in this format here. So 8x to the 5th is yes. And we have b is 5x to the negative 2 would be no, because it has a negative exponent. C is actually okay, because we could rewrite that as 12x to the 0, and x to the 0 is 1, so that fits okay. We can have that as a monomial. X to the 1/3 would be no, because it is not an integer. So so what we're really looking for is, does it have a positive exponent? We don't want things with exponents in the denominator, variables and exponents in the denominator kind of thing. Or like radicals, which D would be like that. Example 6.23, identify the coefficient and degree of each monomial. And so we have a 2x to the 4th. We would have coefficient is 2, and the degree is 4/4. Okay. For 7, we have coefficient is really just itself, 7, because remember this would be like 7x to the 0. Degree is 0. Negative z, the coefficient would be -1, and the degree is first degree. D, coefficient would be -5. The degree, we actually have two different variables, so it's a little bit tricky thinking about that. We actually, to find that out, we would add the exponents together. That's the only case we do that. So the degree would be 4. Okay. And in Math 99, you learn more about this last situation. Example 6.24, rewrite the polynomial in standard form and identify the coefficients, variable terms, and degree of the polynomial. So we want to write it in descending order, is standard form. So we would take our highest exponent, or x cubed minus x squared minus 7x plus 10. Coefficients are, I'll circle those in orange. We have 4. We have actually -1 is the coefficient, -7, and 10, which is also a constant if it's a degree 0. So we have the other thing, variable Terms, degree of the polynomial would be 3, or third degree, we usually say. I think that's about it that we need to know for that one. Variables are x cubed, x squared, x, and x to the 0, if you want to say that one too. They're not like terms, so we can't add any together. For page 80, we have 6.3.1, evaluate polynomial expressions. So we're going to be plugging in this value. You've done some similar things to this before with the smaller versions probably. So try it if you want to just take this -2 and put it in for x, but be careful that you use parentheses when you do that so that you end up with the right signs. Okay, so we're going to plug in this -2 here and calculate. So we have 5 times -2 squared minus 2 times -2 plus 6. Now we're going to calculate, and remember that this -2 squared has to be done first, and it has to be done with parentheses, especially if you're typing in on a calculator, but you shouldn't need a calculator for a lot of these. They're small enough numbers until they get larger. But -2 squared is the same as -2 times -2. We've worked with that before, so that will be a +4. And really make sure you do the exponential first. Follow your order of operations, because otherwise you'll be wrong every single time. So we'll have 5 times 4, and then -2 times -2 is +4 plus 6, and then I'm going to just stretch it out across ways. Usually I like order of operations done one under another, but sometimes now that you know the drill, you can consolidate or go across ways is fine. So then we have 20 plus 4 plus 6 equals 24 plus 6, which is 30, and that is my end result. So I get a value because I plugged in for everywhere I saw x. The common mistake I see sometimes is people will plug in like to one but not the other. They think it's a different thing, but x is x everywhere in that equation. If we have a different equation, then it changes. So this one here, 6.26, go ahead and pause the video and do that one as classwork and then check it. So you should get -15 for your answer. The common mistake I see people making here, again, is they don't do the exponent first. They just include that negative in the base, but that's outside of the base. So 4 squared is what we're looking at first. That is 16. Then we carry that negative down here. Then we just, work our way left to right. Now we're going to look at adding and subtracting polynomial expressions. Remember that like terms are terms that have the same exact variable part. We have to have the same base and exponent. So for example here, -5x cubed does match up to 3x cubed. They're like terms. So we have, for this first one, add -5x cubed plus 6x squared minus 2x, or plus 2x, sorry, minus 7, plus 3x cubed plus 4x plus 1. Now, for this one, we can remove our parentheses. Whatever we have here, we would have to distribute, but it's really like distributing a 1. So we're okay. I'm going to show you that out, though, that we're removing our parentheses, because it's really different if you have coefficients on there, right? So I want to make sure that you realize that it's best to actually go through this process of removing. You could also stack them one on top of each other. That's another method. I'll show you that over there as an alternate. But I have these like terms that I can group together. I could move them around and group them and add them, but I think you're at the stage where, just add the coefficients, I get -2. Keep the variable part and the exponent. Do not change that. It's like having -5. What would be -5? You have 5 apples and you gain 3 apples. You're still, 2 apples kind of thing. So then we have the next one is 6x squared matches up with nothing. So I just go ahead and write that one down. Plus 6x squared because there's no other x squareds. Then I'm going to look at the x's. I have a 2x plus a 4x, and just really watch your signs on these two, plus 6x. And then lastly, we have the constants there, or power of 0 monomials. So we have -7. So again, take your sign with it. -7 plus 1 is -6. And we are not doing any solving here. These are expressions. The only way I'm going to get a result is if I'm, like a one number answer, I should say. If we are actually plugging something in like we did, up here, we plugged in and crunched numbers. So we're going to get a number answer. For here, unless things literally canceled out, like if I had things with the same exact things with opposite signs, I should end up with an expression, not a number. Okay, not one number answer. So really be careful of that. I see people sometimes putting like equals in between here somehow and then solving and give me x equals something. But that's not what we're asked to do. We're just asked to add expressions. And I'm going to show you another way to do this. I just rewrote that first expression right here. And then I could actually add that to the second expression. But when I do that, I need to make sure that I'm actually lining things up properly. So I have a 3x cubed. I don't have any other x squareds in that one, so I'm going to write 0x squared, or just leave it blank. Just know to leave a placeholder. And then I have plus 4x, and then I have a plus 1. And you can just stack it and do it vertical method, and you would end up with the same exact answer. You're going to get -2x cubed plus your 6x squared plus 6x minus 6. So sometimes that helps people to just really organize how they're working the math, but the common mistake again would be not lining it up with like terms. Okay, so here's the answer to your classwork problem right here. So again, you can just remove parentheses, or you could stack them using the vertical method. You get 6x squared y plus 9xy plus 7xy squared. Now let's look at example 6.29. I'm going to show you first the horizontal method where we distribute that negative, and then the alternate method is stacking vertically where we change signs to opposite on the second expression we put down, because we are subtracting these. So we can just remove the parentheses on the first expression, but this second one says negative all this stuff. So don't forget to distribute that negative. You've been doing this kind of stuff before, but there's more complexity here. We have different looking kinds of variable terms with exponents on them. It gets confusing, and if you try to just do this in your head, most of the time people are wrong when I see them doing that. They just don't get them all right. It's hard to keep that in your working memory. So again, first thing we're going to do is remove the parentheses here. So we get 6z cubed plus 2z squared minus 5. Now this one we're going to distribute to every term. It's like a -1, right? So change the signs. So we'll have a plus 3z cubed, a minus 9z squared, a plus z, and a -1. So let's just double check that all our signs are changed to the opposite. Good. Now we're going to combine like terms. So we have a 6z cubed and a 3z cubed. So that's going to become 9z cubed. And then we have a 2z squared and a minus 9z squared. So those are going to become a -7z squared. And then we also have this lone z there, nothing to add it to, so we just leave it as is, plus z. Don't forget about that one. And then we have -5 and a -1, so that will become -6. And that is the answer for this one. 9z cubed minus 7z squared plus z minus 6. Then I'm going to do the stacking method. I'm going to let you pause the video, try it on your own and see how you do, and I'll get that set up and you can check back. Okay, so I've just rewritten the first expression over here, but I left a placeholder there. I wrote in 0z, or you could just, leave it blank. Then I changed all the signs, including the subtraction sign over here, to its opposite. So everything over here got opposite. So it's adding a positive 3z cubed minus 9z squared plus z minus 1. So I distribute the negative through, and I also changed this just to an add because that's how we want to work with it. Now it's kind of like how we did the systems problems, is what this is similar to. So then we go ahead and just calculate, and we get 9z cubed. It's going to be the same thing, right? We've already done this, but minus 7z squared plus z minus 6. So you may prefer one way over another. I usually just distribute, unless it's systems that I have multiple things to work with. I'm usually gonna just distribute that out. Once in a while I'll do the stacking. So that's it for 6.3. I hope you found that helpful, and let me know if you have any questions, and have a great day.